All right, this is the conclusion of my little series here, Where's the Horizon? I had to put 2 videos out because I couldn't get anybody to tell me where the horizon was. You know, as far as ball earthers, I showed them this picture, and I said, where's the horizon? But they wouldn't commit, which is hilarious. Because if the red water level's present in the photo, and it's a real water level that somebody's using and not a picture that I put in, when someone showed that video like this from California, they were quick to jump on this and, yeah, the horizon dropped over there, P-Wayne, look at the horizon, it's so much lower. Well, no, but yeah, they were willing to point out the horizon. But now, when I showed them a picture, they wouldn't point out the horizon. Now, I get it. I've tricked them already with the sun flare video and my Earth video. So, they're a little gun shy. But still, all I asked, I said, just tell me where you think it is. That's all. Just all you can go by is this photo. So I got one taker, Michael Dunleavy. He says, as I told you before, the horizon is between 4 and 6 on the graph. Now, actually, it's pretty cowardice because, okay, so what's between 4 and 6? 5. What's at number 5 here? What looks to be the horizon. But he couldn't say it because he was afraid, okay? He or she, I'm not sure. Okay, so then we got Mr. Sandy comes on my channel, very bold Mr. Sandy. I'm going to give you first place for the horizon is at line number 2. All right, that's bold. All right, that's somewhere up what appears to be in the sky. I like your style there. Okay, so now I want to introduce to you Bob. He is Bob the Science Guy, and he has been my assistant since the Mountain Shadow series because he did such a great job in completely crushing that mountain shadow, like pictures like these, and them claiming that this is due to curvature, that the sun has gone down below the curvature and is shining upward. Therefore, the shadow is going upward onto the underside of clouds above the mountain. Well, thanks to Bob and that little back and forth we did, we completely wrecked it and showed that all shadows are cast downward. I even challenged them with this picture where I put Bob on top of the mountain. I said, you know, show me one picture, just one, from the point of view of the mountain. You know, there are hundreds of mountain climbers. All of them have phones. All the phones have cameras. And not one picture of the shadow cast underneath clouds above the mountain. All of the pictures and video are this, the shadow cast downward, right? Okay, so just a little refresher. Now, this picture is the same as this picture. So this picture on the left is the same as this picture on your right. It's just that this picture on the left is taken from about 10 miles away from the mountain on the ground. And just like these railroad tracks, these parallel railroad tracks will spread out as they approach you, right? This picture on the right is taken from the mountain. And just like looking down railroad tracks, they pinch off and they converge in the distance. So it's the same phenomenon, just 2 different points of view, 2 different perspectives. 2 different perspectives, P-Boy. Your perspective is not going to help you, P-Boy. Okay? So I just want to show you that. It's the same thing. But where I crushed Bob was he was claiming that this picture meant that, see, the sun is down below the mountain and pointing up. But it's just a perspective because when you go to the top of the mountain, this is what you see. Again, thank you, Bob. You are ace. You are ace, buddy. That's why I've hired him on to help me with this video. Okay, let's go on. So he did such great work with that. I brought him on here, and he's got a fancy white lab coat on. Well, I want him to look like he's got a fancy white lab coat because he's going to help me decipher. He's going to teach me because, remember, he is an expert at perspective. No doubt about it. He showed me the light. He turned me on to so many truths about perspective. And now he's going to teach us about shadow. And Bob, try to be light on me, Bob. I'm not as expert as you. I know you are the grand poobah when it comes to this. You are the expert, so please, I'm just a lowly assistant, really, at this point, even though I brought you on to help me. You are the master. You need to show me the light, Bob. Okay, and some of you are wondering, why are you talking about shadows? I thought this is about where's the horizon. Well, you'll see in a minute, all right? Okay, so, Bob, take it away.
P-Brain, shadows seem to confuse you as much as the rotation of the Earth and centrifugal force does.
I know it confuses me, Bob. That's why I brought you on. I need your help. Thank you so much, Bob, for gracing me with your time and your mastering of shadows and perspective. But thank you, Bob. Go ahead.
So let me see if I can help you out a little bit.
Yes, help me out, Bob. That's why you're here. Yes, help us all out. Help all of us flat earthers out that have gotten this wrong before. But with your mastery, you're second to none, Bob. Let's go.
In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see.
It doesn't appear in thin air. Oh, gosh, Bob. How many times I thought shadows appear in thin air. Thank you so much, Bob.
Kind of see how that works now?
Oh, come on. That's not fair, Bob. We're trying.
Maybe?
That's condescension and negativity, Bob. Come on. You're better than that. So the point of this video is to reveal where the horizon is, because these ball earthers couldn't point it out. All right? But before I do, I got to tell you, I did a little something naughty. I stretched this photo out, and now I'm going to unstretch it. And what you'll see is the horizon is actually further away, which makes it higher because things ramp up to your eye level. And if you could see through the haze, you'd see an eye level horizon. Take it, Bob.
Now, P-Brain, shadows seem to confuse you as much as the rotation of the Earth and centrifugal force does. So let me see if I can help you out a little bit. In order for a shadow to appear, it has to appear on something.
Like the ground?
It doesn't appear in thin air, as you can see.
I can see that.
Kind of see how that works now?
Totally.
Maybe? Can you not see that?
Yes, Bob, we can see that. Thank you so much. Man, it's incredible, right? The shadow is cutting through the haze. Nice job, Bob. And the shadow is revealing that the ground keeps going further. You're not seeing it, that's all. And if you're not seeing it manifest all the way out, you're not seeing it manifest all the way up. So when you look at a horizon line and you think, oh, there's the horizon, the apparent horizon, it's not at all. It's actually, it would be higher and it would always be eye level. And this mountain shadow cuts through the haze and shows us. All right, and one more thing about Mr. Sandy. Great job. I think it's probably somewhere between 2 and 3. It may even get to 2. Remember, the sun is higher than the mountain and the shadows cast slightly downward. If the sun were lower, even lower, it could cast a longer shadow. And the horizon may be, in fact, and the apparent horizon may, in fact, be at line 2. So good job, Mr. Sandy. Let's keep going.
In order for a shadow to appear, it has to appear on something. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Kind of see how that works now? Maybe? Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Kind of see how that works now? Maybe? Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that? In order for a shadow to appear, it has to appear on something. It doesn't appear in thin air, as you can see. Can you not see that?
Yes, we can see that, Bob. Great job. You did it again. Who knew the mountain shadow would be such a flat earth proof and expose and reveal so much? Awesome. So what we can see is when anybody shows you these pictures like this and they show the water level and they go, see, the horizon has dropped. Know this. It's just the air is thick and filled with particles, and you cannot see forever on a flat earth. Okay, because when a mountain shadow is present, boom, it cuts right through the haze. Again here from Mount Wilson, California. Look at that horizon dropped. Put a mountain shadow there. If you got the shadow right, boom. There you go. Thank you so much. Thank you, everybody, and my assistant Bob. Give him a hand. He did a great job. He's turned what was his proof of a mountain shadow proving the curvature of the Earth just a couple years ago is now such a strong flat Earth proof because the shadow is always cast downward, as seen by mountain climbers at the summit of mountains. All right, everybody. Thank you, and we will talk to you soon. All right, bye.
Can't imagine many flirts would want to challenge Bob. Oh, you would be surprised. They like to do it all the time. I've got one right now, P-Brain, that is just driving me absolutely insane.